talk about standard, competency standard of graduates, standard of learning content, learning process standards, learning assessment standards, standard of lecturers and educational staff, standard of learning facility of infrastructure, learning management standard, learning financing standard. A lot of work and development that we must do. Hopefully, it makes easier for us to develop our new curriculum, because 2020 we must change our curriculum, and especially correlation with the 3 points of IABEE criteria. I hope in this manner we can have a lot of information about the correlation. Our Ministry of Education and Culture Policy to 3 point of IABEE. Next slide, please. Well, this is my last slide. Actually, I'm a Dean of Faculty of Engineering, Universitas Indonesia, but everybody know well me as a coffee barista in this university. Enjoy this webinar. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Thank you, Dr. Hendri. Hopefully, all the panelists after the pandemic can come and enjoy a cup of coffee in your office.
Yes, sure, please.
Ladies and gentlemen, we will now welcome to our screen the Chairman of Executive Committee of Indonesian Accreditation Board for Engineering Education, Professor Dr. Misri Gozan, IPU. Prof. Misri. Prof. Misri, you are still muted. Prof. Misri, I'm sorry, but you are still muted. Prof. Misri still muted.
Okay, sorry, thank you. Thank you, Tika. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable Dean, Bapak Dr. Hendri S. Budiono, the Honorable Speakers, Dr. Yasuyuki Aoshima from JABEE, Japan Accreditation Board for Engineering Education, Professor Lincoln Wood from Engineer Australia, Professor Dato, Engineer Dr. Hassan Basri from Board of Engineers Malaysia, and my colleague, Professor Dr. Engineer Mhammad Romli, IPU from IABEE. First, I would like to express my gratitude to you all, the speakers, and also for the Dean, for your willingness to be the speakers at this very meaningful opportunity for technical higher education in Indonesia. JABEE, through Dr. Aoshima-san, has supporting us from the beginning of the establishment of IABEE, and also we also get very much help from Engineering Australia, and also from our seniors, Engineering Australia, and also Board of Engineers Malaysia, in establishing our system in IABEE. Professor Romli will explain a lot more about IABEE, but I just want to express here that IABEE was founded in 2015 and started accreditation in 2016. The Faculty of Engineering Universitas Indonesia has full commitment to embrace the accreditation by IABEE since 2017, and almost all study programs, as Mr. Dean said, that FTUI, our Faculty of Engineering Universitas Indonesia, then follow the IABEE accreditation. IABEE very warmly welcome the holding of this event, which is very meaningful to our higher education system in engineering education in Indonesia. And I just want to express here that after obtaining professional status in June 2019, last year, IABEE continues all our effort to prepare ourselves for the full status of the signatory member of the Washington Accord. In Indonesia, there are many parties who welcome the presence of IABEE. You can see that even in this sad atmosphere in the midst of the pandemic, the spirit of developing academic quality assurance in technical education continues to grow. We can see this from more than 200 participants who registered to this event. So without further ado, I will suffice my congratulations here to all the organizers, and also thank again for the speakers, and also thank you for the presence to all participants from all corners of Indonesia, and also from Malaysia, and also maybe some other neighboring countries. Thank you very much, and enjoy the discussions. Thank you.
Thank you, Professor Misri, for the kind welcome to our panelists and our participants. Now, everyone, before we start the keynote session, we would like to take a photo together with all of the panelists. So, administrator and host, if you would mind preparing for the photo session. Spotlight-nya dimatiin dulu. Spotlight-nya dimatiin. Okay. So, please let us know if you are ready. Mr. Habib will direct the photo session.
Okay. 1, 2, 3. One more. 1, 2, 3. Okay, thank you.
So, ladies and gentlemen, we will now begin the keynote sessions. Before we begin the session, please allow me to once again inform you of the few rules to make this session run smoothly. The webinar is recorded for future on-demand playback. Everything will be available later on. The attendees are in listen-only mode. As participant, you will have very restricted rights. You can only see and listen to the presenters and see how many other participants have joined the meeting. Please do not use the chat window. To ask question, please type your question in the Q&A feature on your screen, using the template that the administrator will later inform you through the chat window. In question and answer session, please keep your question on topic and as minimum as possible. Please pay attention to other attendees' questions. They may ask something that you wanted to know. I will read the question on first-come, first-served basis. Direct answer will be given within the 15 minutes question and answer session, and the remaining questions will be answered by text in the Q&A feature on your screen. Today's keynote session will feature talks from 4 keynotes. Professor Dr. Insinyur Mhammad Romli, Chair of International Committee of IABEE-PII, Dr. Lincoln A. Wood from Engineers Australia, Dr. Yasuyuki Aoshima, Advisor to JABEE International Affairs Division, and Professor Dato Insinyur Dr. Hassan Basri from Board of Engineers, Malaysia. We will have a question and answer session after each keynote. Please use the Q&A feature in your screen to ask questions for each keynote speaker. Ladies and gentlemen, our first keynote speaker is Professor Dr. Insinyur Mhammad Romli, Chair of International Committee of the Indonesian Accreditation Board for Engineering Education, and he will give talks with the topic of IABEE accreditation system towards Washington Accord signatory. Before I hand over the screen to him, Professor Romli, with your permission, please allow me to read your brief profile. Professor Romli is a professor of the Faculty of Engineering and Technology, Bogor Agricultural University, IPB. He received his master's degree in biotechnology and PhD in chemical engineering from the University of Queensland, Australia. He has been working for Bogor Agricultural University for more than 30 years, lecturing experience in the areas of agro-industrial pollution control and management and industrial ecology. He has served many positions in the university, including Head Division of Environmental Engineering and Management in 1993 to 2000, Director of Center for Development of Safe Agro-Industrial Process from 1997 to 2000, and Head Department of Agro-Industrial Technology from 2000 to 2008. He is also an active member of PII, serving as chair of PII chapter for agro-industry from 2015 to date. He has extensive experience as an auditor in quality assurance of education, quality and environmental management system, ISO 9001 and 14001, and an assessor of National Committee of Accreditation for Research and Development Institution. Professor Romli, the screen is yours.
Thank you, Chair. Assalamualaikum. Good morning, ladies and gentlemen. I am delighted to be here. I would like to thank the Faculty of Engineering of Universitas Indonesia for giving me the opportunity to talk about JABEE. What I would like to cover in my presentation are these 5 points. First, about JABEE. Second, JABEE accreditation principles, JABEE accreditation criteria, types of accreditation and eligibility, and the rules and procedure of evaluation. So, JABEE is an accreditation agency for engineering and computing education programs in Indonesia. JABEE accreditation is an international level accreditation and is voluntary, unlike the mandatory accreditation conducted by BAN-PT or LAM-PS. Accreditation criteria developed by JABEE follow substantial equivalency requirements set up by the Washington Accord for engineering programs and the Seoul Accord for computing programs. The accords require that the accrediting body is independent from the government. Therefore, JABEE was established as an autonomous department within the Institution of Engineers Indonesia, or PII, in October 11, 2016. JABEE was inaugurated in March 13, 2018. This is the JABEE organization. As an autonomous body, the executive committee is the highest decision maker. We have criteria committee who is in charge of developing the accreditation criteria. We have the evaluation and accreditation committee, which is responsible for planning and managing the evaluation process. And we have here accreditation council who validates the evaluation results. Currently, JABEE or EAC has 2 subcommittees. First committee is Washington Accord, and the second committee is the subcommittee for Seoul Accord. This slide shows the path to becoming a professional engineer. So after graduation, he or she needs to attend supervised training to meet certain competencies. After developing and maintaining experience, he or she became a practicing engineer. So as an accreditation body, the role of JABEE is to ensure that the learning process by the programs is able to achieve the program's educational objectives. IABEE preparation is quite a long process. So after signing the MOU between the government of Indonesia and JICA, JICA appointed JABEE to provide technical assistance. During this period, a steering committee and a criteria committee were formed and began to develop accreditation criteria. In 2014-15, EAC was formed and began to compile the evaluation and accreditation rules and procedures. IABEE has also intensively started promoting the outcome-based education system to universities across the country. Several key personnel were sent also for evaluator training abroad. In 2015-16, the discipline criteria and online evaluation system were developed, and IABEE officially joined under the umbrella of PII. In 2016-17, IABEE held its own candidate evaluator training for the first time. And after carrying out pilot accreditation, at the end of 2016, conducted general accreditation for 2 programs, followed by 3 general accreditation and 6 provisional accreditation in 2017. On March 13, 2018, IABEE was inaugurated. In that year, 28 general accreditation and 18 provisional accreditation were conducted, followed by 12 general accreditation and 28 provisional accreditation in 2019. With that progress, IABEE applied for provisional status in the Washington Accord with JABEE, Japan, and ABET USA as the nominators. In the Washington Accord closed session of 2019 International Engineering Alliance meeting in Hong Kong, IABEE was accepted as a professional member by unanimous decision. In June this year, IABEE applied for the signatory status, with JABEE being the mentor. In the Washington Accord closed session of the International Engineering Alliance online meeting, Washington Accord agreed to form a review team as part of the procedure for applying for the signatory status, also by unanimous decision. However, due to COVID-19, the review team's visit is postponed to next year. This slide shows the difference between IABEE accreditation and BAN-PII compulsory accreditation. So BAN-PII is compulsory, but IABEE is voluntary accreditation. BAN-PII based on input-based evaluation, IABEE outcome-based education. BAN-PII also one-size-fits-all criteria, whereas the IABEE is field-specific criteria. In IABEE-PII, we have ranking system, grade A, B, and C. In JABEE, we have no ranking system. IABEE-PII national level and JABEE is international level, and we put strong emphasis the importance of having continual improvement system. So this is the principles of JABEE accreditation, voluntary. Yeah, the accreditation must be internally driven. So the program should have a good attitude towards quality improvement. It is therefore that the accreditation is not the purpose, rather a means for improving the education quality. The second principle is the accreditation is based on learning outcomes, which is self-determined by the program according to the vision, identity, uniqueness, resources, and the user needs. And therefore, accreditation is not to rank, not to compare among programs. Another principle is international equivalence, international engineering graduate attributes as the basis, and the accreditation is conducted by a third party, independent, autonomous, NGO. And the last one is the nature of the outcome-based education, which is to ensure that the program is accountable to society, because we adopt the outcome-based education to answer the need of stakeholders. So the outcome-based education is the platform for the international level accreditation. Outcome-based education is an educational philosophy or model where the teaching and learning approaches are based on a set of expected outcomes that have been previously set. Outcomes are a set of values or attributes about what must be achieved or mastered by students after completing a certain level of learning. So this is the 12 graduate attributes, elements of Washington Accord. Number one is engineering knowledge, problem analysis, design, development of solutions, investigation, modern tool usage, the engineer and society, environment and sustainability, ethics, individual and teamwork, communication, project management and finance, and also lifelong learning. So this is the basis for the signatories to develop the accreditation criteria, especially that related to the program learning outcomes. It is therefore JABEE formulate the accreditation criteria related to the learning outcomes to address to match all of the requirements specified by the Washington Accord. Okay, now we come to the JABEE accreditation criteria. So the accreditation criteria consists of common criteria. This common criteria applies to all engineering programs. Second one is the criteria guides, explain in more detail the common criteria. We have also here discipline criteria. This discipline criteria applies only for a specific engineering disciplines. And we are going to have also the category criteria, but at the moment we still focus on the S1 programs. So to be accredited, a program shall meet both the accreditation criteria as well as the rule and procedure of evaluation and accreditation. So the accreditation criteria is the reference for program to conduct self-evaluation. The criteria also the reference for IABEE evaluators to review program self-evaluation report, and also as the basis for the IABEE to award the accreditation status. These are two documents describing the rule and procedure of evaluation and accreditation. So we call it RPEA and also RPA-RC. So again, to be accredited, the program must satisfy the accreditation criteria and the rule and procedure of evaluation and accreditation. So these two documents can be downloaded from the IABEE website. Okay, let me explain in a little bit more detail on the accreditation criteria. So the common criteria consists of 4 big criteria following the plan, do, check, and act approach. So the first criteria relates to the orientation of graduate competence. There are 3 elements of criteria here in criteria 1. First is the autonomous professional profile. Second is the publication of the autonomous professional profile. And the third one is the program learning outcomes. The second, the learning implementation. Here we have 5 elements of criteria: curriculum and syllabus, faculty, quality, quantity, role in student learning. Number 3, students and academic atmosphere. 4, facility, adequacy, proper and safe operation. And the last one is institutional responsibility. In criteria 3, this deals with the learning outcomes assessment. So there are 2 elements here: effective assessment of learning outcomes, and second, assurance of learning outcome attainment by graduates. And criteria number 4, this deals with the continual improvement. We have 2 elements here: continual improvement based on learning outcome assessment, and the second one, maintenance and access of documents and records. So this is the common criteria. So common criteria covers all stages of the educational process, from student input, the learning process, graduates, the intended professional profile, and of course, the continual improvement. So, yeah, continual improvement of the program based on the assessment of the graduate learning outcomes. Okay, now discipline criteria. Discipline criteria are additional requirements to accommodate the special needs of an engineering discipline, especially those related to specific learning outcomes, faculty, and curriculum. Currently, we have 15 engineering disciplines criteria which has been developed. From agriculture, biosystem, agro-industry, chemical, electrical, environment, engineering, physics, and so on. 15 discipline criteria. Okay, let me explain about the types of accreditation conducted by JABEE. So JABEE offers two types of accreditation, namely general accreditation and professional accreditation. General accreditation is intended for programs seeking international recognition through JABEE accreditation, and professional accreditation is intended for programs newly adopting an outcome-based education system and have not yet produced graduates under the system. A program applying for professional accreditation will be evaluated to measure its potential of meeting the accreditation criteria within a foreseeable future. Here is the eligibility of applying the general accreditation and professional accreditation. The important one is that the programs applying for the general accreditation are those who has obtained national accreditation status rank A. But the institution accreditation status can be B rank. Okay, this is the evaluation cycle of the accreditation conducted by JABEE. First is the program registration, normally conducted in April. And then the next one is the formation of free conflict of interest program evaluator teams in May. Then the submission of self-evaluation report and program profile. This is two documents required to apply for the general accreditation. And then in July to September, the evaluator will conduct initial reviews and responses from the programs. And we have on-site visit normally in October to November. And then due processes and final evaluation report in December. And then the discipline harmonization, we have two steps of harmonization, discipline harmonization and also EAC plenary meetings. And then the result from this process will be decided by the accreditation council. The evaluation is conducted by a team consists of 3 evaluators, typically 2 academics, 1 industry, but often also involve some observers, either as evaluator in training or other interested parties. Besides the evaluator competence, the evaluator must observe also the principle of ethics, conflict of interest, and confidentiality. This is how JABEE will decide the result of the evaluation. So the program will be judged against each of these 12 elements of criteria from 1.1 to 4.2, as I explained in the common criteria. So there are 4 possible judgments for each criterion, whether acceptable, concerns, weakness, or deficiency. So program will be accredited if there is no deficiency. And the program will get 5-year accreditation or full accreditation if receive A and C only judgment. And the program will get 3-year accreditation interim if the program has W, which means need improvement in the later stage. So this is the accreditation decision, accredited for 5-year period. accredited for 3-year period followed by interim evaluation without site visit if the evidence can be satisfied by the document, and accredited for 3-year period followed by interim evaluation with visit if the evidence can only be verified by site visit. And the last one is not accredited. Okay, so all of the evaluation process is conducted through online evaluation system, since the program application, submission of the documents, review by the evaluator, as well as the reporting, all is conducted through online evaluation system, of course, except for the campus visit, which is conducted on site. However, this year, due to the COVID-19, we are going to conduct also the campus visit using online system. We just finished with the preparation of the evaluation procedure using online system. Okay, so currently we have 117 program evaluators, 80% with academic background and 20% from industry. More than half of this evaluator are those already trained overseas. 44 evaluator trained by JABEE, 16 by ABET, 3 from China, and 3 also visited Engineering Australia. And since 2016, yeah, we conducted our own PEV training programs. So this is how we conduct the PEV, the candidate PEV training programs. We have three or four steps of training. First, the online modular training with focus on the theoretical background or the knowledge on the evaluation process. Second step is the 2-day face-to-face training. This is the simulation of how we conduct the on-site evaluation. So this gives skill to the evaluator to do the on-site visit. And before assignment, the candidate should be assigned as observer. So this will give the real-world experience to do the evaluation. Here are some statistics of JABEE. So the number of eligible programs for JABEE General Accreditation is around 233. So this is around 8% of the total engineering programs accredited by PAN-PT. So we see here quite good growth of the number of programs applying for JABEE accreditation from 2016 to 2020. And we have also good growth on the program evaluators. This is just to show the programs already accredited by JABEE, shows the combination of private institution and also public institution. Yeah, but still the majority is from Java. But in 2020, I think the situation is better because some also from outside Java, from Sulawesi and also from Sumatra. This is sorry. This is the strategy for a program to apply for general accreditation. Of course, they have to study all the document, accreditation criteria, the rule and procedure, and then they have to start to apply the outcome-based education. They may apply for professional accreditation. Yeah, after they have the graduate, then they can apply for the general accreditation. So it takes about 4 to 5 years to prepare for the IABEE accreditation. This is the IABEE website, so all information about IABEE can be found here. And I think this is the end of my presentation. Thank you very much for your attention.
Thank you, Professor Romli. We have two questions in the Q&A, and I will read them to you. The first one is from Delvis Agusman from Mechanical Engineering UHAMKA. His question is, should we get a national first, A or Unggul? I think this means from the accreditation board, from the National Accreditation Board, before international accreditation, or can we directly attempt to international accreditation?
Okay, let me go back to the So this is the eligibility for applying general accreditation. So the program must obtain national accreditation status rank A. Yeah, rank A from the IABEE-PII. And the program should be undergraduate with 144 minimum credit unit, and they apply already outcome-based education in the system. Okay, so I think, yeah, the answer is they have to get the rank A accreditation from IABEE-PII, but the institution accreditation can be rank B. Okay, I think that's answered the question.
Very well. The next question is from Badari Utami from Swiss German University. He asked if the PowerPoint of today's material will be distributed via email. Professor Romli, do we have your permission to distribute the materials later on?
Yes, sure, yeah.
And then the last question is from Mr. Ardian Syahyatim from Universitas Indonesia. He asks, is the accreditation retroactive to previous years?
Sorry?
Is the accreditation retroactive to previous years?
Yes, I think if for example, the program get the accreditation in 2020, yeah, then the period of certificate accreditation applies from the year before, after when the site visit is conducted. Is that the question?
Okay, so we have the follow-up question here from the, Mr. Ardiansyah. If a program is accredited in 2020, will the graduate of 2018 can be considered accredited?
No, this is started from the date of the evaluation visit.
Okay, so it's not retroactive to the previous year,
No,
Professor Romli.
No,
okay.
No.
Very well. Since we still have time, is it okay if I read next question?
Yes, please.
Okay. The next question is from Antonio Sraja Gukuk. The curriculum and syllabus standard criteria apply on IABEE, BAN-PT, and Freedom Learning on Indonesia. How to prepare for it so that the two systems can be applied in parallel?
Okay, I think this is good question. So I think it's good to have one system, one education system. Yeah. So the IABEE criteria made it possible for the program to have flexibility to design the curriculum as long as they address or fulfill the accreditation criteria, such as 20% minimum for the math and basic science, minimum of 40% for the engineering science, and maximum of 30% for the general education. So yes, the program has the flexibility to develop the curriculum as long as meeting the all the accreditation criteria.
Okay. Next question is from Mera Kartika Delimayanti from Politeknik Negeri Jakarta, PNJ. My program is from vocational education. My major is computer and informatics engineering. Is it possible to get accreditation from IABEE?
At the moment, IABEE applied already for the Washington Accord. This is for S1 programs, undergraduate program, 4-year program, 144 minimum credit. Yeah. For vocational, this belong to the another accord. Yeah, which is if 2 years, this is Dublin Accord or technician, and for 4 years program, this is Sydney Accord. But if the question is computing program, if it is correct, yeah? Computing program, this belong to another accord, which is sole accord for computing. Yeah. So.
Okay. Next question is from Nadia from Binawan University. What are the criteria to be the assessor in IABEE, or how to take the training to be an assessor?
Yeah, we have certain criteria for those who interested to apply for the IABEE training. I think you can find the detailed information in the website. Yeah. But yeah, we welcome, of course, the people from UI, from other university to join to strengthen the evaluator of IABEE, yeah, as long as they meet all the criteria. Including the people from the industry, we need quite a lot of support from them, because currently, as I mentioned before, we have only 20% evaluator coming from industry. So we invite also people from industry to join the training.
Okay, now we have a couple more questions, but since we are limited for time, I will read one more question, and then Professor Romli will answer the question directly in the Q&A by text. So the final question is from Vira Rosariawari from UPN. What kind of criteria that the program has deficiency? And the second, are there some information to us about the rule of online assessment? Professor Romli, if you are unclear, you can check the Q&A feature on the Zoom talk on your screen to read the question. From Vira UPN, what kind of criteria that the program has deficiency? And the second, are there some information to us about the rule of online assessment?
Yes. Okay, so the question really is the definition of the what is A, what is C, what is W, and what is D. So acceptable means for particular criteria, elements of criteria, the program fully meet the requirements of the criteria. This is A, acceptable. C, for C or concern, this means the existing condition of the programs, with regard to particular criteria is met already. Yeah, so the program meeting the requirement of the criteria, but the evaluator judge, the evaluator thinks that there will be a certain condition in the future which can violate the fulfillment to the criteria. This is C, concern. Yeah. The weakness means that the program lack of strength to meet the criteria. So the weakness means lack of strength to meet the criteria, and the deficiency is the program completely against the criteria, do not meet the criteria. So this is the definition of the A, C, W, and deficiency. Sorry for the second question. The second question is?
The second question is, are there some information to us about the rule of online assessment?
Yes, this is really new procedure for the evaluation. We just finished the formulation of the procedure, and we are going to have a technical meeting with the programs sometime this month, yeah, to explain to the programs and also to the evaluators about this new procedure. So I think the detail maybe will be available for download in the website sometime, I think in a few coming weeks. Okay.
All right then, ladies and gentlemen, we have run out of time, but we have still 8 unanswered questions in the Q&A feature. Professor Romli will later on directly answer this question via text. And we are now preparing for the second keynote speaker.
Okay.
Okay. Thank you, Professor Romli, for your time.
Okay, I stop the share screen.
Yes.
Okay.
Okay. Our second keynote speaker is Dr. Lincoln A. Wood from Engineers Australia, and he will deliver talk with the title Accreditation as Assurance for Professional Practice, Coping with Sudden Change. Before I hand over the screen to him, Dr. Lincoln, with your permission, please allow me to read your brief profile. Dr. Lincoln A. Wood retired in 2019 from Engineers Australia, where he was National Manager Accreditation for a period of 4 years. During that time, he led a major redevelopment of EA's accreditation management system to be in line with modern quality assurance and risk management practices. Prior to joining EA, he has had alternating career episodes in industry and academy, with the weight of experience being with industry. His industry experience has been in defense, aerospace, and automotive sectors, culminating in an appointment as engineering director for a large defense company in Australia. He has also held professional appointments at 2 Australian universities. Dr. Lincoln, the screen is yours.
Thank you. I think my microphone is on. Thank you, and I wish to greet all respected colleagues all over Indonesia and beyond. I have been a fairly regular visitor to Indonesia in the past and enjoy it enormously. So I'd just like to start. I'll share the screen? Okay. Is that working, Tika? Okay, thank you.
It is.
Thank you. Okay.
Dr. Lincoln, I think you
Okay,
need to make sure that it's on full screen. It's not on full screen yet.
Is
your
it?
presentation.
It's showing on full screen on my computer. I don't know why. Let me try something.
Dr. Lincoln, please click animations. Animations.
I can't. My screen won't select it. It's. I can't get my mouse. Yeah.
Dr. Lincoln, would you mind if we take over your presentation?
Yes, yes. I think you need to. I do apologise. It worked out.
Can you stop sharing screen now?
Okay. Unfortunately, my mouse will not move me onto the screen where I can switch it off. I don't know why. Let me try.
The committee will take over from here.
Okay, now I've got it. Okay.
Okay, Dr. Lincoln, please go ahead with your presentation. Thank you.
Okay, thank you. My apologies for that false start, ladies and gentlemen. My presentation is on accreditation as assurance for professional practice. So it's my pleasure to be invited to make this presentation, and I'm very honoured to have the opportunity to speak. Next slide, please. Just as overview of what I will be talking about, it's in 6 parts. Just a brief overview of principles as a refresher for accreditation. And in fact, Professor Romli's introduction was excellent in this regard. And I'm very impressed with both his presentation and the quality of the preparation that's gone into IABEE's work to date. I'll talk about accreditation not just as quality assurance, but more than quality assurance. And in relation to that, I'll just describe briefly EA's accreditation management system, which in some languages or in some places would be called a QA system. Then I'll just mention briefly EA's current response to the COVID-19 pandemic. And then, sort of inspired by that, noting that there are likely to be other changes in the future, I'll just visit 3 scenarios for future changes after COVID-19, not necessarily driven by COVID-19, and then a brief conclusion. Next slide, please. So, first of all, some brief principles on accreditation. Next slide, please. As we learnt from Professor Romli, accreditation is an outcomes-based evaluation at least in the Washington Accord, it's an outcomes-based evaluation and review process of education programs. It's an evaluation of compliance against defined standards. And those defined standards, as we'll see later, are actually defined by professional practice. Accreditation promotes continuous improvement and innovation. It provides assurance that the program is designed and delivered to prepare students, graduates, for professional practice. Now, I just note that in accreditation, it's education programs that are accredited, not graduates of the programs. This is in contrast with professional practice and licensure, where the attention turns from the education program to the individual professional. So it's a different perspective, it's a different focus once the graduate enters professional practice. Next slide, please. In accreditation, the terms quality assurance and risk management are often used in association. Quality assurance enables an organisation, or in this context, the accreditation activity, it enables an organisation to achieve its purpose. And risk management evaluates the effect of uncertainty on the likelihood of attaining that purpose. So you can see that they effectively go hand in hand. For example, well, I will pass over the examples from EA because you will have copies of the slides. I also need to introduce, or just to mention, that there's quite a bit of text on my slides. The reason for that is I have presumed that people will want to look at them afterwards, and so I have put sufficient text in so that they can be used after the seminar for people to review them without needing to go to other sources of reference. Next slide, please. So, risk management in association with, or versus, if you like, innovation and change. What are the comparisons? Well, outcomes-based accreditation allows innovation and change by minimising the degree of prescription as to how the program meets its program learning outcomes. But also, genuine innovation may introduce very significant risk profiles, especially in the short term. In the longer term, that risk will become bedded down, but in the short term, that risk may be very significant. So a simple application of the outcomes-based approach may not be adequate to manage the extremes of risk-bearing innovation, and we'll talk about one of them later, and that is, just briefly, artificial intelligence. Accreditation policies and procedures need to outline risk management approaches, and effective risk management is essential to innovation and change management. It also helps to manage external challenges such as the COVID-19 case, and we'll look at that shortly. Next slide, please. So now I will just briefly address the purpose of accreditation and the associated purpose of education, which is not just quality. That is, that accreditation is more than just quality assurance. Quality assurance is absolutely essential, but it's the purpose of the quality assurance and the purpose of education that we need to examine. Next slide, please. So I'll use this diagram several times, so I will only introduce it briefly here. The one perspective, a QA perspective, as assurance of the education program, is that the education program, which is the box in the centre, delivers the educational intentions, which are expressed as program learning outcomes, as educational outcomes, and these are the graduate attributes of the program, which are which is, in the case of the Washington Accord, are aligned with the IEA's graduate attributes. Next slide, please. So the purpose of accreditation really is assurance for professional practice. An entry to practice qualification provides two key capabilities, and that is the initial professional competencies to function at an appropriate level when first joining the workplace, that's upon graduation, and the full academic basis upon which experiential learning can be built, and sufficient for the workplace competencies to then be developed to achieve licensure. So that little diagram just is that representation. Next slide. And next slide too. Back one, please. That's it. The ultimate target of accreditation is licensure. And the ultimate target of education is licensure as well. Though the immediate target, of course, are the graduate attributes, or the initial professional competencies, which are shown at the middle. But in all that we do in accreditation, we should keep our eye on our target in professional practice, and that'll become clearer as hopefully later as we develop. Next slide, please. So the full QA perspective considers the ultimate purpose or the target of accreditation, which is professional practice. Next slide, please. And that professional practice is represented there by that section on the right, the professional career. Now, it's interesting here that we draw the professional career as like a fan. Engineering is quite different to most other careers, many other science-based careers. If you think of medicine and maybe physiotherapy, the physiotherapist's first day in the office as a professional licensed physiotherapist basically is working on strained muscles. Their last day in their office, when they retire from their professional career, they are working on with their clients strained muscles. The engineering career is quite different. What one experiences as a new graduate is very, very different typically to what one experiences and what one is working on in the last day in their office of their professional career. So that's the reason why we draw it like that. Next slide, please. The initial professional competencies, as we have seen, are defined from the graduate attributes, which are compliant with the IEA graduate attributes, and these are deemed necessary for early career performance within the profession. I won't dwell on the example from Engineers Australia because the IABEE example of its professional attributes, graduate attributes, is excellent. So I'll pass over that. Next slide, please. Just now, looking briefly at EA's its accreditation management system, which is a QA system, what many people would call a QA system, but EA does not use that terminology. It uses AMS as opposed to QA system, and that's because it's actually looks beyond QA, if you like. Next slide, please. The AMS is the expression by Engineers Australia of how it achieves its accreditation purpose. It's comprised of various artefacts, standards, policies, procedures, etc. And those artefacts are the collected wisdom of experienced personnel assembled over many years. Its scale of the management system is proportional to the complexity and risk inherent in the accreditation activity. And the output of the AMS is the register of accredited programs, but the outcome, which I keep referring to, is assurance for professional practice. Next slide, please. So why have the AMS? Well, right at the moment, we are very pleased that we have recently updated and extended our accreditation management system because it enables us to manage more effectively with the COVID-19 situation. It's a means of exerting management control and demonstrating it to the management board of EA and also the accreditation board, which is an independent board set up within EA. It enables effective and efficient working to produce consistent and reliable outputs. It's an effective form of risk management as well as risk management policies embedded within it, and it supports organisational learning. And ultimately, like I keep saying, it provides assurance of competencies suitable for initial professional practice. Next slide, please. The architecture of the AMS we don't need to dwell on, but it's fairly standard policies, standards, manuals, handbooks, etc. Some of those must be available to users external to EA, to education providers, but there are many artefacts that are internal or back office use only, and these record the detailed working processes for preparing and managing visits, and that's been invaluable in our current situation. Next slide, please. So then this management system is an evolving and living system. It is regularly updated, extended, and improved. It needs a lot of care, a lot of work to remain in a fit, healthy, fit for purpose state. And of course, users should be trained in its application. And it's pleasing to see the IABEE's training in the use of its management system. It should be pragmatic with enough detail to achieve management control and not too much detail to discourage users. And it encourages innovation and continuous improvement through risk management. So risk management, continuous improvement, innovation, accreditation are inherently linked. Next slide, please. Now, I'll just mention EA's current response to the COVID-19 pandemic, and just note that the impact of the pandemic is still evolving, so EA's response can also be expected to evolve accordingly. So it's a part of the it's a dynamic response. But as I'll point out, one of the features that enables us to respond in this dynamic way is the flexibility given by the accreditation management system. Next slide, please. So in reality, probably like most other accreditation bodies around the world, EA was already well positioned to cope with the current crisis because of the outcomes-based procedures and standards. This provides flexibility when demonstrating compliance. The inclusion of a risk-based approach in accreditation policy, and that actually explicitly allows within the policy, or the policy explicitly allows a 1-year extension of the accreditation period if risks can be managed. Also, it's a feature of EA's accreditation because we measure the accreditation term from the intake of students, not when they graduate. The policy also, it commences the accreditation period from the year following the visit. That effectively gives an extra 6 months of flexibility for organising a general review visit. So built into it, into our management system, is actually the ability to extend an accreditation, to extend a visit period by up to 18 months. The self-study reports and supporting evidence have moved to electronic submissions, as I believe is the case in Indonesia, many other bodies as well. We already conduct most special reviews online. These are distinct from general reviews, and thus the management processes for that are actually well proven, well adapted, and already at work. And we also, with our recent overhaul of the accreditation management system, have a very authoritative and trusted system, and it enables business continuity in times of disruption and facilitates remote working. Next slide, please. Now, more specifically, what did EA do? Well, EA's Accreditation Centre engaged with education providers directly, basically polled education providers to discern their needs, consulted with the Accreditation Board and experienced accreditation personnel as to what options and approaches may be applicable. It noted the advice issued by the Australian Government academic regulator, known as TEXA. It issued advice to universities at about the same time or just prior to EA. And it also invoked the means available in the AMS to defer general reviews. And the special reviews have continued with minimal interruption, and special guidance was issued to education providers. Next slide, please. So that special guidance was in the form of a special policy document, a limited term policy document. It noted the features of outcomes-based accreditation. It confirmed, very importantly, that the accreditation standards remained unchanged. So there's been no watering down of accreditation standards. It provided advice for managing changes to professional practice elements, which was a major concern for many universities. And it distinguished between temporary and continuing changes. It advised of allowable rescheduling of accreditation visits, and also confirmed continuing engagement with IEA. Next slide, please. Now, just noting the COVID-19 changes, so we can maybe think a little more about what changes may occur in the future. And I'll look at three potential scenarios. One is, well, I'll go straight into them. Next slide, please. Before I do that, actually, I'll just note that the nature of most changes across many endeavours, we tend to think of them as always being evolutionary. The reality is often the opposite. Most often very often they're sudden and very dramatic. We may see them coming, but even so, when they do occur, they're unexpected and can result in crises. And change can be from any source. There can be social, geopolitical, economic, technological, etc. And it's been said that the world is likely to be a very different world in the next 10 years, and not just because of COVID-19. So it's probably worthwhile that we think about the nature of change and how to manage it. Major change, of course, creates uncertainty and risk, but successful negotiation of change requires a very clear understanding of the fundamentals of what it is that we're doing. And we talk just briefly about that as well. Next slide, please. The first scenario I'll point to is one that I've been very familiar with, having an industry background, but it's likely to accelerate in the post-COVID-19 environment. In many ways, because of industrial disruption, the industry is likely to drive, these changes are likely to drive greater pragmatism by employers. Even now, even when I was recruiting in industry, even then, employers did not ask graduates, what are your graduate attributes? They say, what roles can you do? That is, employers recruit to fill defined roles in engineering teams, and those roles are not explicitly aligned to the graduate attributes. They're underpinned by the graduate attributes, of course, but the roles are not defined in terms of graduate attributes. These changes are likely to be driven by industry, not by education providers or professional bodies. So accreditation, as we know it, could in fact be supplemented by other forms of professional recognition of learning. And one example that's held up is, of course, micro-credentials. And that's an interesting one to explore. But importantly, though, it would seem to me that accreditation is likely to remain a reference point or a beacon, as I say, for safely navigating this future. So accreditation won't go away. Next slide, please. Another interesting one is that of cross-professional teams, and I also have some prior experience with this. It's been said that engineering designs are a hypothesis of how we live. But that's also the science of anthropology. Anthropology studies how we live in society. So anthropologists and ethnographers in some organisations are already advising on incorporating user experience concepts in some design teams. Intel do that in the US, and I believe some automotive companies already do that. But I think that what we might see in the future is non-engineers being like anthropologists, ethnographers, psychologists, being routinely embedded in engineering teams as designers, designing the user experience alongside engineers. And so, and it's already happening to an extent in human factors engineering. So what does this mean for the expected graduate attributes of engineers? Well, I'm not going to answer that question, but it may be something that accreditation will need to think about in the future. Accrediting bodies will need to think about. Next slide, please. The final example or scenario is the impact of artificial intelligence on professional judgment. Basically, professional judgment uses the full cognitive spectrum from the attentive or front of mind spectrum that we often assume, we certainly rely on, but also subconscious processing, which is also known as emotional processing. Next slide, please. Without going into a full explanation of how professional judgment is formed, we just note here, I just note that professional judgment employs both the emotional processing and analytical processing ends of the spectrum. We could talk a long time about this, but this is independent research has shown this. Next slide, please. So, AI, artificial intelligence and professional judgment. Well, engineering is an information profession, so it is very likely that artificial intelligence is going to exert huge influence on professional practice, especially attentive processing, which was the right-hand side of the screen, the previous slide. And that involves the interpretation of task input information, generation of task outputs, that's generating information, and also the inherent knowledge base, noting that AI does not forget, unlike humans. So AI is an information tool, so AI is certainly going to be influencing the attentive processing side of engineering professional judgment in the future. But it's quite different when we look at the experience base and pattern recognition, which comes from experience. AI cannot replicate or probably even simulate emotional processing. So how is this going to affect professional standards, and how will this affect accreditation in the future? And this isn't even asking the question, how is AI going to change education, which is also an interesting question. So again, I won't answer the question. I'll just move on to the final slide. Next slide, thank you. Next slide. Thank you. So this is the final slide. So just looking to the future, and just to what accreditation agencies and engineering education providers will need to do in the future. They will need to have a very clear understanding of the fundamentals. It's not just the fundamentals of education, but it should be a very clear understanding of engineering practice, and the nature of design. They will need to have a very clear understanding of professional judgment. They'll need to understand how ethical codes will function in a cross-professional environment. And importantly, in times of change, they will need to understand how to maintain trust in the profession, bearing in mind that professions like engineering really only operate because they are trusted by the society in which we operate. So that concludes my presentation, ladies and gentlemen. Terima kasih. Thank you for listening.
Thank you, Dr. Lincoln. Ladies and gentlemen, we will now start the question and answer session. And we have 3 questions already for you, Dr. Lincoln. If you can also open your Q&A chat box.
Yep.
The first one is from Guntoro from Malik Saleh University. His question is, how risk management and innovation can effort to accreditation?
Does that mean how will it affect accreditation?
Yes, I think so. Or how can it be of beneficial towards the accreditation?
Okay, I'll answer the question with that understanding. Risk management identifies risks in advance or anticipates risks, and then makes allowances for their management. Risk management doesn't just identify risks, but it's a proactive activity to not just anticipate them through identifying them, but to act in advance. And this facility is most effective when it's written into accreditation policies and procedures, which is what we have done in Engineers Australia. I suspect many other agencies do. What it does is it allows it allows a management process to be established which provides visibility of how the risk is being managed. And accreditation is about providing education providers, providing confidence to an accreditation body that its program is going to meet the accreditation criteria, not just now, but throughout the entire accreditation period. And with visibility of the management processes for the risk, then an accreditation board can make an informed assessment of the likely effectiveness of that risk management activity. We have found that in EA to be very, very powerful and very effective. And we would we think it's probably one of the better things that we have done in recent years, to be honest. It was always there to some extent, but it was recently formalised in our policies and procedures. I hope that answers the question.
Okay, the next question is from Delphis Agusman from Mechanical Engineering UHAMKA. How about material composition between basic science, mechanical engineering, and general science? Because if adopted a strictly similar curriculum, how to improve ourselves as our competitive advantage?
Well, again, if I understand the question correctly, outcomes-based accreditation does not prescribe, it does two things. It doesn't prescribe inputs. So it doesn't say what you need to do. It just says these are the output standards that you must meet. And it gives you the flexibility to choose how you will prove compliance with those standards. So it's in its extreme application, outcomes-based accreditation gives actually extreme flexibility to education providers as long as they can show how they meet the accreditation standard. So that is the primary advantage of outcomes-based accreditation. So that is probably the best, I think the most appropriate response to the question as I understand it.
Thank you, Dr. Lincoln. And for the last question is from Dr. Basri from Universitas Indonesia. What should Indonesian engineers take licensure so he or she can work in Australia as professional engineers? Is the Washington Accord-based accreditation engineering program is recognized in Australia professional engineers? Thank you.
Okay, the all Washington Accord-based accredited activities, including those from Indonesia, are recognised by Engineers Australia. So the academic program, which is what forms, as we saw earlier, the basis for building experiential learning, that education program is fully recognised in Australia. We do not impose any other academic requirements. Then Engineers Australia will look at the experience that the applicant has, and it's that then the experience is the remaining determinant as to whether or not that person can achieve licensure. I would also say, though, that already there is nothing to stop Indonesian engineers or any other engineers actually to work as engineers in Australia, because licensure is not mandated across Australia. It is not mandated by government. There is a degree of licensure being introduced in some states, but it's not fully, it's not a full licensure program. So unlicensed engineers can work in Australia, do work in Australia. Some roles require licensure, but licensure does not require, in fact, one can work throughout one's entire career in Australia without being licensed, professionally licensed. But a Washington Accord education program is definitely required.
All right. I think we have answered all your the question for your session, Dr. Lincoln, and at 5 minutes early. So thank you very much, Dr. Lincoln.
Thank you.
Okay, ladies and gentlemen, we will now begin the third keynote speaker. The third keynote speaker is Dr. Yasuyuki Aoshima, Advisor to Japan Accreditation Board of Engineering Education International Affairs Division, with his talk entitled JABEE's Lesson Learned for the Future of International Accreditation in Engineering. Before I hand over the screen to him, Dr. Aoshima, with your permission, please allow me to read your brief profile. Dr. Yasuyuki Aoshima was born in Shizuoka, Japan in 1947. He finished his bachelor degree in civil engineering from the University of Tokyo in 1970 and his doctoral degree in steel structure from the Federal Institute of Technology in Lausanne. He joined UNESCO from 1982 to 2008 and later helped the establishment of the Indonesia Accreditation Board for Engineering Education in 2013 to 2014. He currently serves as the advisor for Japan Accreditation Board of Engineering Education International Affairs, as well as chief advisor for JICA project for IABEE. Dr. Aoshima, the screen is yours.
Thank you. The title of my keynote is JABEE's Lesson Learned for the Future of International Accreditation in Engineering. Can you display the slide? Yes, and next please. This slide shows, before my real presentation, I would like to share the definition of engineering with you. According to Oxford Dictionary, engineering is activity of applying scientific knowledge and design, building, and control the machine, roads, bridges, electrical equipment, etc., etc. This is true, but I don't like that definition, because from this definition, people think science is upstream and engineering is downstream. There is another definition of engineers. Engineers are people who don't wish a problem away, but wish to start doing something to solve it. There is a big misunderstanding by general public, media, and politicians that science and engineering are the same discipline. Scientists, engineer, they are very similar people, but it's not true. Scientists, they are interested in the discovery of the truth of the nature. But engineers, they want to solve the problem of the society. So it's a big difference. So now, after having said that, I want to proceed my presentation. Please, next slide. Engineering is the most advanced field in the quality assurance in professional education. In Western countries, historically, professional societies such as an institution of professional engineer or Council of Engineers have been conducting the accreditation of education to ensure that the younger generation, next generation, have acquired required ability and knowledge when they have graduated from engineering study programs. In those countries, only graduates from accredited programs are eligible to be professional engineers. Next slide, please. IABEE-PII, United States, was established in 1932, before the World War II. Washington Accord established in 1983, 30 years ago. But in Japan, Japanese university did not have culture of quality assurance of education until 2000. JABEE triggered the outcome-based quality assurance of university education in Japan, such as, of course, for JABEE's case, engineering education, in other accreditation for pharmacy, medicine, nursery, and the teacher. Next, please. The Washington Accord, it was established in 1989 by 6 accreditation bodies for engineering education in Australia, Canada, UK, Ireland, New Zealand, and United States. They are all English-speaking, so-called Anglo-Saxon countries. The accreditation bodies of the Washington Accord signatories accredit study program with similar criteria. It means not with one simple worldwide criteria, because the engineering is different from one country to another. The needs of engineering is different from one country to another. So the criteria of accreditation is different from one country to another. So Washington Accord, each country accredit their program according to their criteria, but the old criteria are similar under the Washington Accord. And as a result, they recognize substantial equivalency of accredited program under the Accord. Next, please. So this is the current Washington Accord membership. The left column show the name of the abbreviation of agency, and in parentheses in the country jurisdiction. And the middle column show the years that those body became provisional status of the Washington Accord, and the right column show the year show that those member agency became signatory. So in the first line, 6, this is the funding members: IABEE-PII, Engineer Canada, ECUK, Engineering Australia, Ireland, and New Zealand, and followed by Hong Kong, South Africa, very short time, because the Hong Kong, South Africa, they're under the British culture. It was easy for them to join Washington Accord. And the Japan JABEE became a provisional member 2001, and 4 years later, JABEE became the signatory. This is the milestone of the Washington Accord, because Japan is the first non-English speaking country who joined the Washington Accord. Education in Japan are conducted in Japanese. the accreditation, evaluation of the study program are done in Japanese. But when Japan joined the Washington Accord, other Washington Accord, mainly English-speaking country, they accepted the system developed by JABEE is equivalent to other signatory of the Washington Accord. And after Japan, Singapore, Korea, Chinese Taipei, and Malaysia, and now recently India, Sri Lanka, Pakistan, they became the signatory of the Washington Accord. Now, today there are 21 signatories of the Washington Accord, and the majority are from Asia. And also in the down part, there are still 8 countries who have already obtained the provisional membership and looking for signatory status, including Indonesia. And the next slide, please. This is the International Engineering Alliance structure. There are 7 constituent agreement and accord who are the members of the International Engineering Alliance. The group, left group, this is Educational Accords group. There are 3 accords: Washington Accord for engineers, the Sydney Accord for engineering technologists, Dublin Accord for engineering technicians. And the right group, this is the mobility agreement. And there is in the end, the APEC engineer. And in case of Indonesia, PII is a member of the APEC engineer. And the IABEE is the provisional member of the Washington Accord. So those group, 7 constituent, they have a dream that someday a qualified engineer can work across the country board. Japanese engineer can work in other country and vice versa. So this is the dream of all engineers people. Next one, please. And the JABEE, now I'm talking about the JABEE's experience, lesson learned. 1997, JABEE set up the preparation committee for establishment of JABEE. And 1999, JABEE was established. And it was started accreditation 2001. And on the same year, we got the provisional status. And 4 years later, we got the signatory status of the Washington Accord. And the Washington Accord system, every 6 years, the signatory status are examined by other Washington Accord signatories. So 2012, the first periodic review was conducted, and 2017, second periodic review was conducted. Next, please. I'm not now talk about the little bit outside Japan. There was a paradigm shift from input-based teaching to outcome-based learning. In 2000s, ABET, United States, drastically changed its evaluation method from input-based to outcome-based. ABET triggered the world paradigm shift of engineering education from input-based teaching to outcome-based learning. The Washington Accord adopted OBE, outcome-based education method, for evaluation. So now study program shall set up learning outcome, taking into consideration what the student shall acquire rather than what the professor wish to teach. Next slide, please. That one, this is the graduate attribute. This is the knowledge and ability that the graduate of the study program should have acquired when they graduate. But that 12 item have been already explained by Professor Romli's PowerPoint, so I'll just skip. Next, please. And there is in the Washington Accord philosophy that the complex engineering problems are important. The complex engineering problems cannot be solved without in-depth engineering knowledge, and they may need multi-disciplinary approach. This is important. They involve wide-ranging of conflicting technical, engineering, and other issues. They need appropriate considerations of public health and safety, cultural, societal, and environmental considerations. In many cases, the complex problems have several solutions, sometimes no solutions. But study program should teach the student that there is a complex problem that engineer should tackle. Next, please. And also, there is another important aspect, the concept of engineering design education. So there are study programs should teach the student that ability to identify a problem that is expected to be solved, and the ability to identify restricted conditions such as public welfare, environmental preservation, and cost which are expected to be considered. And also ability to logically identify, organize, and investigate the problem that is expected to be solved. The ability to establish a plan to solve the problem, considering the restrictions and by applying body of knowledge of mathematics, science, and technology in each applicable field. And finally, ability to actually solve the problem in accordance with the plan that is established. Next, please. Now I'm talking about the lesson learned of JABEE's experience. When JABEE became the signatory of the Washington Accord 2005, 1 year before, the Washington Accord review team visited Japan. And then this is the extract of the summary, executive summary of their team report. Please look at the down, the third paragraph in red. They said that Japanese engineering education somewhat different from other countries. In 2004, Japanese education is not the same as other Washington Accord countries. And what is the real meaning? Please look at the first paragraph. They said that Japanese engineering program emphasize the learning of relevant scientific principle, the only theory, more than the application. It means Japanese university engineering education did not provide real application of engineering. So this is some, of course, criticism, but strong advice from the Washington Accord to JABEE to improve the Japanese engineering education. So since 2004, JABEE made a lot of effort, and also university study program, they made a lot of efforts to change the Japanese engineering education. Next, please. So 7 years later, JABEE received a first periodical review by the Washington Accord signatories. And at that time, the report said that they recognize the improvement of engineering design education. So we are very happy. we received the homework. Multidisciplinary teamwork is not sufficient, because in the IEA graduate attribute, teamwork is necessary. But in Japan, civil engineering department work only civil engineering people, and the mechanical engineering people working only mechanical engineering people. They are different company. There is no collaboration among the department. So since 2012, we made efforts, also a study program, to introduce multidisciplinary teamwork. And 5 years later, we received the second periodic review team, 2017. And the report recognized JABEE's flexible application of multidisciplinary teamwork. What does it mean, flexible? If we put multidisciplinary teamwork in our common criteria, what's happened? Because today, majority of the Japanese study program, they do not conduct multidisciplinary teamwork. So all those programs will not be accredited, because if it is written in the common criteria. So JABEE decided not to mention multidisciplinarity in the common criteria, but we put in the criteria guide why we need multidisciplinary teamwork. And with the in 10 years or 20 years, let's make efforts that we change the Japanese education towards the multidisciplinary teamwork. So the Washington Accord review team appreciate that kind of flexible application, because it's not only JABEE, but also other countries, they are challenging to introduce multidisciplinary teamwork in their education. And then at that second periodic review, we received another homework. At the end of the paragraph, evaluation of quality of program evaluator is not systematic. So it means the program evaluator is the most important expert for accreditation system. But without the evaluation of quality of program evaluators, their good accreditation will not be possible. So this is still the homework for Japan to set up, introduce a more comprehensive, systematic evaluation system of evaluators. Next, please. There are different international frameworks of accreditation of education for so-called engineering field. Washington Accord for engineer, JABEE is the signatory, and the Seoul Accord, computer science, IT, JABEE also signatory. And also we have Canberra Accord for architect, designers. JABEE is the signatory. We have also in Europe, EuroAce for engineer, and the Sydney Accord, engineering technologist, and Dublin Accord, engineering technician. But JABEE are not, for the time being, are not interested in joining for the last three framework. Next, please. There are a lot of negative attitude of accreditation and the JABEE accreditation by Japanese universities. And of course, JABEE takes measures. The first one is the educational institution. Universities in Japan are very tired by a lot of evaluation. First, they are asked to do self-evaluation, and also institutional evaluation enforced by law, like BAEE-PII in Indonesia. And also, although it is voluntary, optional accreditation, JABEE's accreditation program is another additional work. And also, sometimes study program at the university, they are not happy with JABEE evaluation teams. JABEE's evaluation, likely as other Washington Accord signatories, evaluation is a peer evaluation. It's not audit. It's not inspection. It's a peer assessment. But when someone is appointed as an evaluator, they are so proud and they tend to look down the study program. But unfortunately, every year, one or two such an inappropriate evaluator behaves in front of a study program. I am the evaluator and I am superior to you. And that kind of attitude harm the trust of JABEE system. And also, I'll skip and please go to next slide. And also, a lot of universities in Japan do not yet understand the advantage of accreditation. And there is a lack of importance of perception of third-party evaluation. So some study program, they have once been accredited by JABEE, and a few years later, they quitted JABEE system, saying that, thank you very much, it was a good experience. Now we can do it by our own. But it's not third-party evaluation, it's self-evaluation. And the next two slides, please. This slide shows that the Washington Accord accreditation is not giving a ranking. That already explained by Professor Romli. I will explain in a different way. That horizontal red line, this is the level required by the Society for Education. And P1, one study program, P1, they set up gray. They set up learning outcome to be achieved for the program, much higher than that red line. And green column show that the top students graduated after having acquired the learning outcome. And even the lowest students also have acquired the learning outcome set up by the program. Then JABEE, Washington Accord signatory, we accredit that program. Please look at now P4. That P4 program set up learning outcome higher than the P1. But the students, bottom students, they graduated without acquiring the learning outcome. That program, JABEE and Washington Accord signatory do not accredit. We are not interested in P1, P4, which is better. It's not ranking. And P3 program, they put the program put the learning outcome so-so. just on the same level of the required level of the society, but all the students have graduated after having acquired the outcome, learning outcomes. Then we accredit that program. Number 2 program, yes, all the students have graduated after having acquired the learning outcome set up by the study program. But the learning outcome set up by the study program is below the level required by society. That such kind of program we do not accredit. Next, please. This is a little bit old data of 2 years ago. I want to show in each country, some countries, how many study programs are accredited by their national agency for each study program. The United States, ABET is the accrediting agency. California Institute of Technology, this is the, at that time, that university is a #1 ranked by the Higher Education Times. And that program, 3 study programs are accredited by ABET. The third, MIT, 21 study programs accredited by ABET. And if you look at the Canada, same, Australia, etc., etc. So you can see many of the countries, top universities, study program are accredited by agency, which are the Washington Accord signatory. Next slide, please. Now I'm ready to explain the situation with Japan. #1, according to Higher Education Times, University of Tokyo is #1. No program are accredited by JABEE. Kyoto University #2, no program accredited by JABEE. So this is the situation. So this is really the challenging issue for Japan. And since I am the project manager of a JICA project to assist Indonesia to establish IABEE, I don't want to repeat that miserable Japanese situation to Indonesia. Fortunately, top university of Indonesia, such as UI, Gajah Mada University, Bandung ITB, IABEE, ITS, and some good university and private universities, they are all agree to be accredited by IABEE. So I think IABEE's future is not like Japan. This is you should be proud of the leaders of Indonesian top universities. And then since the top university are committed to be with IABEE, so other next group of universities, they are convinced that they should go to IABEE accreditation system. Next, please. Why accreditation? That slide is already explained by Professor Romli, so I don't want to repeat again. And before going to next slide, I want to tell you one joke, my joke. In my slide, in the beginning of my slide, I told you that the ABET was established in 1932, before the World War II. And the JABEE was established 2001. 1999, just 20 years ago. At the World War II, Japan lost the war against United States. Of course, Japan didn't have accreditation body, but ABET already at that time, they have accreditation body and accredited engineering study program. This is why Japan lost the war. So this is my joke. And now, next slide, please. I want to report the JICA Technical Cooperation Project in Indonesia. This is a 7 years project from 2014 to 2021. The first outcome should be establish IABEE, done already, and develop criteria, accreditation criteria, done already. Some accreditation agency in other country, they just copy of ABET criteria and translate into local language. But the IABEE, they didn't do it like this. IABEE people, they studied all the criteria of the Washington Accord signatory and studied which criteria is better suited for Indonesia. And they selected finally ABET and the JABEE accreditation criteria. And on the basis of two information, IABEE people created their own criteria. So this is the very unique efforts made by Indonesian people. And develop program evaluation procedure and instrument. They are all digitalized, online. We don't produce any paper for evaluation documents. We evaluate the study program online. JABEE, we have also online system, but IABEE system is much more advanced. I think IABEE digital evaluation system is the most advanced system today in the world. And train IABEE expert, which was explained by Professor Romli, in Japan, United States, China, and Australia. And those trained people now train other evaluators in Indonesia. And today there are 117 evaluators are trained. And we organized a socialization seminar to education institutions and conduct accreditations. And we got, IABEE got the provisional status in the Washington Accord 2019, and we are looking for the study signatory status in 2021, but unfortunately, due to COVID pandemic, that will be done in 2022 in the earliest scenario. Because to be a signatory status, 3 Washington Accord evaluators will be visiting Indonesia to examine the IABEE system and also observe at least 4 study programs, IABEE's evaluation of 4 study program. And then the report will be discussed next year. And if all the signatories unanimously agreed with the report of the team, then IABEE can be a signatory and I hope for pre-2022. And this is my last slide. Next one, please. JABEE accredited 4 study programs in Indonesia in the framework, under the framework of JICA project. So this is not IABEE accreditation, this is JABEE accreditation using JABEE criteria, using JABEE evaluators. But during the four evaluations, the Indonesian expert observed the JABEE evaluations, and they consider like as a training purposes. So 2014, this is the first study program agreed by JABEE, Mechanical and Biosystem Engineering of Bogor Agricultural University, and next year Islamic University of Indonesia, Civil Engineering, and Metallurgical Engineering, ITB, and 2017, Department of Chemical Engineering of University of Indonesia. So this is my presentation. Thank you very much.
Thank you, Dr. Aoshima. And next, we will see the question and answer feature. We have 4 questions for you. Oh, actually 3. Okay, I'm going to read the first one. The first one is from Nadia Paramita from Environmental Engineering, Binawan University. The question is how to fulfill the multidisciplinary teamwork according to Washington Accord requirement into the curriculum. Is it conducted as a student final research or as a specific subject or lecture?
Okay, we are not asking that the study program, that all the time the classroom are a mixture of multidisciplinary students. But from time to time, the project basis, we invite not only civil engineering, but also mechanical engineering students, sometimes economics or law department, etc., to understand what is the teamwork. Because once they have graduated from the university and they work in the private sector or government sector, we all work with different people, multidisciplinary people. So at the university level, from time to time, the program should provide the opportunity to students to learn what is the importance of multidisciplinary teamwork.
Okay, the next question is from Mr. Rahmat in Universitas Indonesia. How does quality assurance of Japan higher education work when the number of program accredited is too little, too few?
It is very difficult question to answer. So this is really the dilemma of Japan JABEE. We are challenging, but there is no solution. No solution today.
Okay. Perhaps you will.
Don't worry. Don't worry. In Indonesia, it will not be the case.
It will not be the case in Indonesia then. Okay, let's move on to the next question. It's from Mr. Sri Harjanto from Universitas Indonesia. He said that he graduated his PhD from Tohoku University, and it is interesting to know the experience of JABEE according to the presentation of Aoshima Sensei, that many top leading universities in Japan is not accredited by JABEE. I would like to know what are the main reasons that they have resistancy to the accreditation of study program in engineering. Does this affect the credibility of JABEE, and how JABEE handle this issue in the present and in the future?
Okay, this is almost the same question as the second question. Huh? So,
I'm sorry?
This question, number 3, is almost similar to number 2. So my answer is already, we are challenging.
Okay, let's move on to question number 3. From Antonio Rajaguguk from Universitas Riau. Based on the evaluator exists, there are problems that are not systematic, according to you. Number 1, how to be systematic and what needs special attention, and also why it is difficult to do so.
Okay, when I was the CEO of JABEE, I want to introduce a systematic evaluation system of program evaluators. But some people say, we are a volunteer. Why volunteer should be evaluated? So this is a very, very special culture. So finally, because of that kind of resistance, we couldn't materialize the evaluator evaluation. But we have not given up. We will certainly, one committee is continuing to introduce a systematic, it means 360-degree review. So team chair evaluates, evaluator evaluates team chair, and evaluator evaluates other evaluator. Also, study program evaluate the team. So these kind of systematic 360-degree evaluation will be conducted. First, sending the questionnaire to everybody who have contributed to the evaluation procedure.
I'm still muted. Very well. And then we come to the last question. This is from Tiana G. Amran. Although quality assurance and risk management have a significant effect on the way education system in Indonesia, in the education system, however, in Indonesia, it is still not working. Your comment on that, Doctor?
Sorry, what is the RM?
Risk management, I think.
Risk management. Okay, I think as Dr. Lincoln mentioned it, and also Professor Romli mentioned that the accreditation is not the purpose. Accreditation is a mean to improve the education. So today it's okay if the program doesn't have QA and RM, but they have to make efforts. And we have to encourage that effort. Through the accreditation is not the one spot evaluation. This is a continual evaluation for continual improvement of education. So don't worry if your program has not yet have the that kind of system. You can do with IABEE.
All right. I think that wraps up all of the questions for your session, Dr. Aoshima. Thank you very much.
You're welcome.
And now we will move on, ladies and gentlemen, to our fourth and final keynote speaker. Our fourth and final keynote speaker for the day is Professor Dato Insinyur Dr. Hassan Basri from the Board of Engineers Malaysia, with his title topic, Board of Engineers Malaysia's Experience on Accreditation of Engineering Programs. Before I hand over the screen to him, Dato Hassan Basri, with your permission, please allow me to read your brief profile. Professor Hassan Basri is currently a visiting professor at the Faculty of Engineering UNICEL, a board member in the Board of Engineers Malaysia, and chairman of the Engineering Technology Accreditation Council Malaysia. He is the past chair of the Malaysian Council of Engineering Deans, as well as past chair of the Engineering Accreditation Council from 2005 to 2007. He played a key role in transforming engineering education in Malaysia as prerequisite for securing Malaysia's entry into the Washington Accord, the international agreement for mutual recognition in the accreditation of engineering degree programs. For his service to engineering education, he received an Achievement Award from Board of Engineering Malaysia in 2013 and was admitted as Fellow of Society for Engineering Education Malaysia in 2012. In engineering TVET education, Professor Hassan is actively involved in the Engineering Technology Accreditation Council since 2013. He was appointed as its pro-tem chairman in 2012 and was active participant in Malaysia's efforts in securing full signatory status of the Sydney and Dublin Accord in June 2018, the international benchmark for engineering TVET. He is currently a member of the Cabinet Committee in Technical for TVET Empowerment and the Special Task Force on the Future of Vocational Colleges. Professor Hassan Basri, the screen is now yours.
Thank you very much, Chair Ibu Tika. Let me now share my the screen. Is this one? Share. My respected co-speakers, colleagues from IABEE and Universitas Indonesia, and also participants from all over Indonesia. First of all, thank you very much, IABEE and Universitas Indonesia, for inviting me to speak in this webinar. Indeed, I'm honored to have been given this opportunity. So the topic of my presentation is engineering program accreditation in Malaysia, the BEM experience, perhaps giving a slightly bigger, wider overview, because I believe a lot of the details on the accreditation aspect has been dealt with by the previous speakers. So the contents of my presentation, first a brief overview of the engineering profession in Malaysia, the legal framework for engineering education. Then I will mention briefly on engineering TVET. This, I think one of the questioners earlier has asked something related to this. And something about the engineering team is regulated by the Board of Engineers currently, and then finally concluding. First, BEM and the engineering profession in Malaysia. As in other countries, Malaysia needs more engineering professionals for national development. The backdrop is the increasing demand for engineers in developing countries, as similar in Indonesia as well. So the case of Malaysia is typical, with a population much smaller than Indonesia, 32 million. Why are engineers important? I will show a slide introduced to us by our mentors many years ago, 15 years ago. A graph showing the relationship between engineers and the GDP. GDP is, as we know, one of the major indicators of how advanced a nation is. And the graph is a straight line relating the x-axis, engineers per million population, and GDP in the y-axis. So the more advanced countries would be in the top right side, and the developing countries bottom left, and Malaysia is still probably within the developing countries category. We are still, the number of engineers is still low compared to the advanced countries per capita. This table shows engineer population ratios. Malaysia, we have 32 million Malaysians, 162,000 registered engineers, and the ratio is 1 engineer for every about 200 Malaysian. In Japan, probably the highest performer, the data from your ministry, Dr. Aoshima, is 2.5 million engineers for a population of 1 to 6. So the ratio is 1 engineer for every 50 Japanese. In Germany, is 1 for every 82. And perhaps slightly less for Canada and UK. I don't have the figure for Australia. So we need more engineers. That's the point. So the Board of Engineers Malaysia, which I'm representing, there's also the IEM, which is more of the association, the Learned Society, with a register of about 30,000 members. Compared to BM, we have registered persons in total 170,000. So BM is an independent statutory body by Act of Parliament, formed in 1972 under an Act, the Engineers Act. The latest amendment is in 2015. And the primary role is to safeguard the safety and interest of the public. So basically, we are a regulatory body. And in doing this, we do the registration of engineers, engineering technologies, inspectors of works, and engineering consultancy practices. And to regulate the professional conduct and practices of registered persons and also the companies registered with the board. The independence of BM is enshrined in law. As some of us may be aware, one of the criteria for admission into the accords is that the body must be independent as a professional body in engineering. So for the Board of Engineers, there is a clause in the Act, Article 28, which says that for any act done in good faith by the board or those authorized by it, no action or proceeding shall be instituted or maintained by any court. That means we are probably the highest decision-making body for engineering matters in the country. So no court of law can challenge the decision of the Board of Engineers Malaysia. Of course, even the government, the ministers, or even the Prime Minister will not be able to interfere. This is our act, can be downloaded from the website, and this is our website. Next, the legal framework for engineering education. We have several acts covering accreditation. There is the MQA Act, and of course our own act, which mentions accreditation as well. Under the MQA, the Malaysian Qualifications Agency Act, professional bodies are empowered fully for accreditation of related study programs. So for the medical programs, it will be under the Medical Council, the relevant professional body. For law, by the Bar Council, for example, and for any engineering program, it will be under the Engineers Act. And under the Act, we have to form what's called a joint technical committee under articles of the MQA Act. So our ETAC BM and EAC BM, the council, both councils under BM, are actually legally under the framework of the MQA Act, called the Joint Technical Committee. And this committee has the full mandate, just accept the application process, which is via the MQA, the full mandate given to the professional bodies. And BM has full mandate over diploma and degree programs for engineering and engineering technology, and of course the technician level engineering programs. These are excerpts from the Act, but as I mentioned, both Acts, MQA Act and the Engineers Act, can be downloaded from the internet. And these are the articles of the Act which refer to accreditation. So under the both Acts, we form what is called the EAC, Engineering Accreditation Council of Malaysia, which is the Joint Technical Committee of the MQA Act, delegated by BM under mandate by the law. This is for the conventional engineering degrees under the Washington Accord. The other council, which I am chairing at the moment, is the ETAC, or the Engineering Technology Accreditation Council of Malaysia, established 2013, 7 years ago. This is the Joint Technical Committee also of the MQA Act, delegated by BM, and this covers what we term in Malaysia as engineering TVET, the practical hands-on education and training for engineering. And this is governed internationally under the Dublin Accord and the Sydney Accord. And the degrees in Malaysia, they are called for the technician level, Dublin Accord, the diploma level, either in engineering or engineering technology. And for the degree level, for the engineering technologies, degree in engineering technology. Historically, we started, accreditation started in 1967 at the bottom here, where accreditation is done by the government, the Public Services Department. And then in 1959, just 2 years after independence, the Institution of Engineers Malaysia was formed. This is, and they took over the accreditation. And then in 1967, it was jointly done by both IEM and the Board of Engineers. The board was formed in this year, by the way, 1967. In 1996, the establishment of the National Accreditation Board, Lembaga Akreditasi Nasional, but this is like a government department, and it was upgraded to, and following that, BM established the EAC, Engineering Accreditation Council, with the view of joining the Washington Accord in the year 2000. And then in 2007, the MQA was formed under a separate act on its own to ensure independence. And this replaced the government agency before this called LAN, and then the NAB. And in 2013, the establishment of the ETAC, the Engineering Technology Accreditation Council. And for the Washington Accord level, we have a standard called the EAC Engineering Program Accreditation Standard, also downloadable from the internet. Similarly, for under ETAC, which in Malaysia we consider them as the engineering TVET sector, the Sydney and Dublin Accord levels of education. We have the two standards also available, downloadable from the internet. First is the Engineering Technology Program Accreditation Standard. The latest version is this year. And the Engineering Technician Education Program Accreditation Standard, also latest published this year. This is the latest version, by the way. And the pandemic issue, we have issued a document called Guiding Principles on Teaching and Learning and Assessment during COVID-19 pandemic. This is also downloadable from the internet. We just Google this phrase and the thing will appear. You can access the link there. Basically, these guidelines just give a broad, as emphasized by speakers before this, in outcome-based education, we specify the outcome. So the universities are pretty flexible in delivering their program, just as long as the outcomes are achieved and they can demonstrate that, it is Okay, that means these guidelines highlights the problems encountered during the pandemic and what are the possible ways of overcoming them while still demonstrating that the outcomes has been achieved. So it's fairly general, but the universities are given the message that they can be flexible and innovative in delivering their courses as long as they ensure the outcomes are achieved. Perhaps I will just summarize with that, but if you are interested, you can download this document from the internet. We also have a policy on naming and content of education programs under the board. So since we are now fully signatory, we are signatories of the all three education accords under the International Engineering Alliance. We also publish a policy for all universities to conform on how to name the program so that the public is not confused, because if it is a free for all sorts of names will be offered by many universities in Malaysia. And the IEA has been explained earlier, and Malaysia, we are committed to benchmark against the world's best, and this is one of our efforts. And we talk about the engineering team at the engineers level. We are the entry level for education is for the Washington Accord. The engineering technologies level, the entry level is the for education is Sydney Accord. For the technician, which we call in the Act, it is referred to as inspectors of works. It is the Dublin Accord level. And this Sydney and Dublin Accord is what we term as engineering TVET in Malaysia. The focus on engineering TVET, perhaps I'll just briefly mention on this. It's quite a significant thing because significant perhaps can be seen from the most recent budget for the government. So in the last 2 years, government budgets, all of the ministries or all the sectors, the allocation has been decreased except for TVET. So the government has embarked on a national TVET agenda where they are trying to encourage more and more TVET education and training of TVET nature. And the Board of Engineers has latched on to this and supported that move by the government by clarifying for the engineering, for the TVET programs of engineering nature, there are certain standards which they can benchmark on, and we have used the Dublin and Sydney Accord standards to formally categorize a big sector of the TVET landscape as engineering TVET. And we believe that engineering TVET should be more in terms of numbers compared to conventional engineering. I mentioned here the mark of advanced engineering nations is that engineering TVET is bigger than conventional engineering. And conventional engineering under the accords is the Washington Accord, and engineering TVET, the practical side of engineering, is the Sydney Accord and the Dublin Accord for the technician level. Everybody in Malaysia is now asking, what is engineering TVET? Perhaps it's relatively new to many here. TVET, also known by other names, this is the list of acronyms or the alternative names for TVET. But the official definition by UNESCO is the acquisition of knowledge and skills for the world of work. So it's a very simple definition, acquisition of knowledge and skills for the world of work. And what is engineering TVET? So similarly, it is the acquisition of knowledge and skills for the world of engineering work. And this is the world of engineering work from the so-called lowest level, just selling machines and so on, to the highest level, so-called highest level, theoretical research. This is all the world of engineering work. But our Registration of Engineers Act actually define what is engineering works. It is all works which include public utilities, building machines, equipment, processes, works, or projects. So anything that require the application of engineering principles and data. So it is enshrined in law that any work which has some form of application of engineering principles and data, then it is legally considered as engineering work and will be under the purview and under the regulatory purview of the Board of Engineers Malaysia. And so what is engineering TVET? It is basically TVET of engineering nature, engineering that is of practical orientation, hands-on nature, compared to conventional engineering as we know it, as defined by competencies and graduate attributes of the IEA. So the IEA defined these competencies and graduate attributes for the three categories, the technologies. So this one will be for the technologies and for the technician level graduate attributes. So for the Dublin and Sydney Accord, and as in any country, in Malaysia, a big portion of TVET is actually engineering TVET. More than 50% of engineering nature, the programs offered by the polytechnics and so on in Malaysia. So what is the difference between conventional engineering and engineering TVET? Overall, it's more practice-oriented. The outcomes are determined by workplace requirements. Student intake, you will have access to a wider pool of school leavers because the more the so-called non-theoretical oriented students can be given an opportunity, and the curriculum will have a minimum requirement of 50% practice-oriented content, and it can be even up to 100%. The curricular focus, the maths components are more practical than theoretical in nature. Deep theories in maths and science are not necessary. So the words we use in the requirements for the mathematical and the sciences is applied. So it should all be applied in nature, and work-based learning is very much encouraged. And if possible, all of program delivery can be done in industry, but all the while it must meet the graduate attributes or the program outcome as determined by the graduate attributes document under the Sydney and Dublin Accords. So by benchmarking internationally, we are more confident in specifying what are the minimum that is required. I will also say that engineering education has always been of TVET nature. There is an article I will not read this, but I think perhaps I will read this. I have time. There is an article by Kaplan Lasseson in 2017. In October 1957, the Soviet Union launched Sputnik. The world's first artificial satellite was only as big as a beach ball, but it produced outsized effects. Sputnik not only spurred the US-USSR space race, but also drove scientific, technological, political, and military developments. Among those was a change in engineering education. To develop engineers who could help the country reach the stars, academia shifted away from a hands-on focus to a more theoretical one. Engineering programs increased their emphasis on math, physics, and engineering sciences, and removed lab courses. Engineering technology programs offering both associate and baccalaureate degrees, this is in the US, took on somewhat engineering had dropped. So the point here is that originally engineering would have been of TVET nature. That means it's always been determined by what sort of work you will do. Next, briefly talk about the engineering team as has been covered in our Engineers Act. So the last amendment, as I mentioned earlier, was 5 years ago. And in these new amendments, we have added the registration of 2 new categories in red, that is engineering technologists and the technicians, which are termed as inspectors of works. So previously, it's all engineers. By the way, also since 2015, there is no mention of nationality. So any graduate of any recognized engineering program from any country in the world can register as engineers or technologists or technicians in Malaysia. So this all is also, and of course, those graduates must be graduates of Washington Accord or Sydney Accord accredited program. So this gives all the more importance for countries of the world to adopt this world standard under the IEA. The latest statistics in Malaysia, we have registered of 153,000 engineers. Engineering technologists, not as many, just under 9,000, and the technicians are registered. Of course, not all are registered with us. For technicians, it's only 6,700. And the mission of BM and the nation is to increase the number of the engineering professionals to reach 320,000, so that we are at par with the advanced nation benchmark. We are targeting of 1 engineer for every 100 Malaysian. So 320,000 for the engineers for 32 million Malaysians. For these 2 components, we are also targeting to enhance greatly, as indicated earlier. We foresee that the number of engineering professionals will not be increased mostly in this category, but more in the practical hands-on category or the engineering TVET category. Just as a comparison, in Germany, they have the number of hands-on engineering programs, the so-called Fachhochschulen, is 2 times the number of the so-called university engineering program, the theoretical engineering program. So the engineers graduating from the hands-on universities in Germany, the practical-oriented Germans, what they call now as the Universities of Applied Sciences or the Fachhochschulen, is 2 times more. And the graduates, I believe, is also along that proportion. So who is this engineering technologist? It's actually the practical-oriented engineer. There is an article about this profession from the quote that I mentioned earlier. You can just Google it, and it can be available readily from the internet. And actually, the work they do is pretty much similar. This shows the overlap, and the overlap is about 90% what engineering technologists do and what engineers do. This is from the ASME, or the American Society of Mechanical Engineers document. I think some countries do not differentiate. I've spoken to Dr. Aoshima before. For example, Japan, they don't. They are all called engineers. And there is a need to regulate the engineering team in Malaysia, at least, including accreditation of their education and to benchmark against world standards, and hence why Malaysia is already inside the Washington Accord 11 years ago into 2009, and 2 years ago Sydney Accord and Dublin Accord, so that our education is not detached from the world standard. Concluding remarks, we hope that the engineering graduates in Malaysia are now recognized worldwide with these 3 accords, benchmarked and accredited with the international gold standard of the IEA. Thank you very much, gentlemen.
Thank you, Professor Hassan Basri, for your presentation. Ladies and gentlemen, we will now open the question and answer for everyone that has question for Professor Hassan Basri, please type in your question in the question and answer feature. We don't have any questions yet. For the last keynote session, keynote speaker, any questions? So we have enough time for several questions. So we're going to wait for a little bit, Professor Hassan Basri. Do you have anything else to add? It's very interesting that you are involved, especially in the vocational studies for accreditation. In Universitas Indonesia, we also have vocational studies, although not for engineering. But we have Polytechnic Negeri Jakarta and a few other established polytechnic that are focused in the vocational studies for engineering. I don't know. Have you how is it different for undergraduate and vocational? What are the focus for each program for accreditation?
Perhaps I just mention another point, perhaps also in relation to your indirect question, that the landscape of TVET education in Malaysia, we have a total of 44 polytechnics offering diploma and degree level programs, and half of the programs are engineering programs. In addition to that, in addition to the 44 polytechnics, we have 89 vocational colleges. And I think 1/3 of the programs are offered by these vocational colleges are engineering in nature. So this, the providers of TVET education, including, which I mentioned earlier, that a big portion of those TVET education are actually engineering in nature. They are the number of providers are actually more than the education providers for conventional engineering, which are provided by the universities and university colleges. So in Malaysia, there is the infrastructure is there, but there is now the extra effort being made by the government to increase the number of engineering professionals, and by increasing that number is not via not increasing the number of the conventional engineers, which is very difficult to do, because to get students to be interested doing high-level theory in engineering is not easy. So by trying to empower and expand the scope of engineering TVET education, we hope that we can proceed better along that line in meeting the number of the benchmark of 1 engineer for every 100 Malaysians.
That is interesting that you mentioned professional engineers, because the question that I have already found in the question and answer feature from Hairul Razak, he asked whether in Malaysia has an advanced professional education, such as professional engineers that we have in Indonesia, that several universities, including Universitas Indonesia, already has, and whether to take that professional engineer program, one has to graduate from undergraduate program or sarjana, or diploma 4 is enough.
There is a pathway for any graduate to become a professional engineer. So the professional engineer qualification is the professional level, which requires at least 3 years, normally 5 years of professional experience after a Washington Accord degree. So there is no program offered by any university for this next level after the Washington Accord level degree program. So it's just a matter of acquiring professional experience under the mentorship of a professional engineer, and the Board of Engineers, together with the Institution of Engineers Malaysia, have an assessment framework to admit the graduate level engineers to become professional engineers. As for diploma level graduates, they will have an educational pathway to achieve, to become either an engineering technologist or a graduate engineer. And from then on, they can become professional engineers under the given professional pathway that is specified. So the answer to that, there is an educational and professional pathway for every level of graduate of programs, engineering programs accredited by the board at all 3 levels, Dublin, Sydney, and Washington Accord levels.
Thank you, Professor Hassan Basri, for your answer for the question. Ladies and gentlemen, we now have come to a close because we've already finished answering all questions for the 4th keynote speaker. Professor Basri, thank you very much. And this is the end of today's online seminar. We hope that you have an enjoyable seminar and gain some useful insights from our keynote speakers on the topic of quality assurance in international accreditation of engineering education, present and future. All materials will be given to those who needed them. Please email our secretariat or our committee just by replying the email that we have sent before, informing you of the Zoom meeting link. We would like to once again thanks to all of our keynote speakers for making the time to share with us your knowledge and experience. We would also like to thank all of our participants. We have 148 attendees, 140 attendees, but we record around 148 previously. And we also have around 20 people watching our live YouTube streaming. So thank you very much. We would also like to say on behalf of the organizing committee, apologize for any inconveniences or any technical difficulties that may have happened during the online seminar. We would like to say goodbye and thank you, and we hope to see you again in a future online seminar. Thank you, everyone.
Thank you, Prof. Hassan. Thank you, Pak Aoshima-san.
Thank you, everybody.
Prof.
Thank you.
Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you.
Thank
Very
you,
nice.
everybody.
Terima kasih, Pak Romli.
Yeah.
Thank you, Dr. Lincoln.
Terima kasih, Professor Lincoln.
Yeah. Thank you. I enjoyed that. I apologize for the problem at the start. I discovered that it was because I had a second screen.
I see.
Okay.